Let's talk about Chapter 5. Chapter 5 deals with bonds, bond valuation, interest rates. And we're doing this chapter right after the time value of money chapter on purpose. And you'll see why as we go through some of the slides here. So we'll talk about bonds, bond valuation, how to measure the yield on a bond. And we'll talk a little bit about risk, because when you talk about bonds, you have to talk about risk and what's the risk of owning a bond and not getting paid back. So this is the slide we kind of start every chapter with, and they point an arrow down to what we're talking about here. So we're talking about the cost of debt. So we're going to kind of figure out what that means. From the corporate side, we're looking at bonds as the main source of debt for corporations. They have the ability to issue bonds. Investors buy these bonds, and then in return, the corporation has to pay out dividend payments. I'm sorry, not dividend, interest payments, and then repay the principal of the bond when the bond matures. Okay, so key features of a bond. So there's a lot of terminology around bonds, so I'll just kind of warn you about that. Remember that in your ebook, at the end of every chapter, there is a list of terminology with every chapter. So that'd be a good list to review kind of before you get too deep into the homework for Chapter 5. Just make sure you've got a decent handle on what some of the general terms mean. That will help you quite a bit. And as you go through the ebook, keep in mind that any term is kind of bolded with an underline. You can click on that and the definition kind of pops up on your screen. So it wouldn't hurt you just kind of familiarize yourself with some of the key terms from the chapter. There's just a lot about bonds. So just FYI, that'll help you with the quiz and some of the information that you'll be working on. So in this chapter, they're going to use $1,000 as the par value, just to make it simple and easy. Now, in reality, most corporations are issuing bonds for like $1 million or more than that. I mean, you can issue any face amount you want, but there's a lot of overhead when it comes to issuing bonds. There's a lot of filings and regulatory things you have to do. So if you're going to do it, you need to issue a large amount in the millions of dollars to make it worth the company's time. We don't have to worry about that. We're just going to look at it from a $1,000 perspective. So par value is what they call either the face amount. It's the amount paid at maturity, basically the principal value of the bond. And again, we're giving these $1,000. They talk about coupon interest rate. That's the interest rate literally stated on the contract. So just think if you had a bond contract in front of you, there'd be an interest rate stated on that contract. It's called the coupon interest rate or the stated rate. We multiply par value by this rate to get the dollars paid in interest, and generally it's fixed. Now you can buy bonds where that fluctuates based on some indexes. Let's don't worry about that for us in this class. That's not an issue. Just basically say whatever that rate is, it's the same for the whole life of the bond. So then again, the bond matures. When the bond matures, that's when it has to be repaid. So years until the bond must be repaid, and that declines. The further the closer I get to the bond maturity date, that number goes down. Keep in mind that bonds can be 10, 20, 30 years. It's not unusual to have a 30-year bond. Okay, so companies can issue a bond today and repay it 30 years from now. So the issue date, the date the bond's issued, and default risk is the risk that the issuer, the person who bought the bonds, has to deal with in case the issuer is the person who's issuing the bonds, the company issuing the bonds. So the default risk is the risk of the bond owner not receiving interest payments or principal payments because the company that issued the bonds can no longer afford to pay for them. Okay, it's called default risk. So with any debt, that's always a concern, default risk. When the bank gives us a loan for a car or a home or a credit card, there's always that default risk that the bank has to worry about, right? So basically saying, what happens if this person I gave a loan to does not pay us back? So a call provision is when a bond issuer, a corporation issuing bonds, basically says in the contract that me as the issuer, if I'm the issuer, and you as the students are the people who bought the bonds from me, but I put in the bonds a call provision. And you would know that. I mean, that wouldn't be a secret. You would know that when you bought the bond. That means that if interest rates change and it becomes affordable for me to refinance the bonds, I have the right to buy them back from you as the investor. Okay, so issuer can refund if rates decline, helps the issuer, hurts the investor. So therefore, borrowers are willing to pay more and lenders require more on callable bonds. So what that means is if I'm the bond issuer and you are the buyers, the investors of the bonds, in order to get you to buy those bonds from me, knowing that if interest rates fall, I'm going to call them back, I need to pay you a premium. It's called a call premium. I have to pay you a little bit extra. So instead of paying you $1,000 to buy those bonds back, their face value, I have to pay maybe $1,050 or something like that. So that call premium is called a deferred call, or usually with most bonds, that will go down over time. It'll be a high amount to start, but it will go down over time. A sinking fund is a provision that a bond issuer would put into place to set money aside in some organized fashion to pay off the bond. So keep in mind that quite often these bonds have a 30-year maturity. So if I'm a corporation and I sell you bonds today, the risk is, will I be around 30 years from now to pay you back, right? If we would have went back in time 30 years, okay, you'd have to go, and we bought Sears bonds 30 years ago, we'd be thinking, that's pretty safe. Sears, big company, been around a long time. They'll be able to pay us in 30 years. Well, lo and behold, Sears is no longer a viable company, right? So that you never know. But if Sears had a sinking fund in place, so they've got some provision that's contractually they're obligated to follow, the odds of Sears defaulting goes way down. Okay, so it reduces risk to the investor, can also shorten maturity. Not good for investors if rates decline. So one possible way that this works, there's several ways that these sinking funds work, but one way, let's just say I'm a company, I'm a corporation, I've issued bonds, and you are the buyers, and it's a 10-year bond. And what I promised is every year I'm going to recall 10% of the bonds randomly. So I'll just put all the bonds, literally in a paper bag and draw 10% of them out. And then I'm going to buy those bonds back every year. And I'm contractually obligated to do so. The bond contract states that I will do this. So you buy the bond knowing that there's a 10% chance every year that the bond will get called. Well, that reduces your risk tremendously, right? So you know that the company has to have the money set aside, contractually obligated to do that. However, you just don't know how long you're going to own the bond. So you got to be willing to do that. So it's a safer bond because there's less risk, but you may not get the return that you want either. So that's kind of the give and the take with that kind of a situation. Or you could promise just to buy them on the open market too. So I could call so many back per year, or I could basically say that I will buy X% of the bonds back on the open market. And then you would have the option to sell or not to sell back to me. So if I'm just going to buy them on the market, you don't have to sell them back to me. But if there's a call provision, then you have to sell them back to me. Okay. So this looks kind of messy, I'll have to admit. And this should look familiar from your time value of money chapter. It's just a timeline, the timeline approach to valuing an asset. Keep in mind that in finance, we value assets based on the present value of cash flows. And you can see here, it's exactly what I'm doing. So bonds have two cash flows. So I have a 10-year, 10% coupon bond, $1,000 face value, because that's what they use as a default. And so with that in mind, kind of think through what that looks like. 10% times 1,000 is $100. So I take the coupon of 10%, I multiply that by the face value of 1,000, that equals $100. So that's how I get the $100. So let's say I'm the bond issuer and you're the person who buys these bonds. I'm going to pay you $100 a year, every year for 10 years. On the 10th year, I'm going to give you the $1,000 back. So you give me $1,000 today, then every year for 10 years I give you $100, and then in the 10th year I give you $1,000. Okay, and so the present value of all those cash flows equals the present value of the bond. Okay, and I can show you that calculation. It's really simple. I'm going to go back to the Excel file that's right here. This is the one I gave you for your time value money chapter. And bonds are ordinary annuities, so it's really simple. So when you're valuing a bond, like we are here, always think present value of an ordinary annuity. So go back to my Excel. I've got the present value of an ordinary annuity. And the payment is the face amount of $1,000 times the coupon interest rate of 10%. Okay. Then the interest rate that I use is, it says if R sub D is 10, is 10%. That's the market rate of interest. And keep in mind that interest rates on the market fluctuate daily. If anybody's ever bought a home and your mortgage lender is asking you to quote-unquote lock in your interest rate, you're watching interest rates on a daily basis, trying to find the day when rates are going to be lowest, right? So interest rates fluctuate daily just based on market conditions, no different than the stock market fluctuating on a daily basis based on market conditions. So, but in this example, R sub D is 10%. Okay, so I'm going to use 10%, and then N is 10 years. And and I also have to put in the future value of $1,000. Okay, then I get exactly $1,000. And the reason it's exactly $1,000 is the coupon rate of 10%, my 0.1, is exactly the same as my market rate of 10%. So that's the $1,000 value that you see right here. Okay, and they're going to show us the exact same thing here using either a calculator, financial calculator, or using Excel. And just just imagine these are the inputs right here that are highlighted as the exact same inputs that I plugged in here. So now the question is, what if there's inflation and the R sub D, the market rate of interest, is now 13%? So every other scenario is the same except the market rate of interest, this one right here, is now 13%. Okay. Oops, I got to type in 0.13. Let me do that right. I get 837.21. It's exactly the same number right here. And then flip it the other way and say, what if the market rate's 0.07? And if I type in 0.07, I get 1,002.1071. Okay, so everybody sees that number right here. So the key with this little exercise we just did, the coupon rate never changes, right? That payment is based on the coupon rate of 10% times 1,000 for $100. What does change is the market rate of interest. So bond prices fluctuate based on the market rate of interest. Okay, so that's what makes a bond price change, the market rate of interest compared to the coupon interest rate. So just want you to kind of keep that in mind. All right, so let's come back and look at some more slides here. And then, of course, the other situation is years to maturity. That affects bond price too. So suppose the bond was issued 20 years ago, and now it's 10 years to maturity. What would happen to its value over time if the required rate of return is either 10, 13, or 7? And the key that I kind of want you to remember is that bonds, we amortize them. The closer they get to time zero, so a 30-year bond, you can see based on different interest rates what the values were. The coupon rate's 10. But up here, we've got different rates based on being 7 or 13%. But the closer I get to maturity, that comes down to $1,000. So these values, no matter what we sell a bond for, no matter what's valued for on the date of issue, when it matures, it comes down to $1,000. Okay, so that graph kind of shows you how that works. Okay, so at maturity, the value must equal par value, and that's the key with that one. That's why you see the premium bond coming down to 1,000, the discount bond rising up to 1,000. Okay, so yield to maturity. Just think of what that means. Yield is a return. Yield is interest rate to maturity. And what that means is this is the yield that I'll receive if I buy a bond and I own it until it matures. Okay, so if I bought a 30-year bond today, and I'm an investor, and I buy that bond, and I intend to own it for 30 years, my yield to maturity is the rate of return that I'll receive by owning that bond until it matures. Okay, also called a promised yield, because the company that is issuing the bond is contractually obligated to pay that back, right? They're going to pay the interest and then the principal when the bond matures. And of course, the big assumption here, we assume the bond won't default. That would change the yield to maturity. Okay, so YTM on a 10-year, 9% annual coupon bond, $1,000 par that sells for $887, and we want to find what's the R sub D. R sub D meaning what is the yield to maturity, and it's really simple how you do this. And so this looks kind of complicated, I'll have to admit, and this looks really, really complicated, I'll have to admit, but that's why Bill Gates invented Excel. Okay, so that's why it exists, to make that's a little bit tongue-in-cheek there when I say that. So we want to just go back to my Excel file, and we've used a formula already, and it's called the rate formula. So let me scroll down, and I'm going to solve for I interest rate. Okay, so if I solve for this, that'll get me to my YTM. So let's go back and look at the inputs. So it's 10 years, present value is 887, payment of 90, future value of 1,000. Okay, and I get 10.91. So let me just show you what I did again. I did that really fast. So I just took these inputs here that they gave us on this problem, 10-year bond. It sells today for $887. That's the $887. That's the present value. It's the sale price today. The coupon payment is $90. The future value when the bond matures is $1,000. That means its yield to maturity, the R, is 10.91. Okay, 10.91. Okay, so the yield to maturity in that bond, if I bought it today for $887, I own it for 10 years, my yield would be 10.91. Okay, so just some rules of thumb. So as you do some of your homework problems, this is a good rule of thumb to have in front of you. So this is slide 19. So if you either want to print this out or jot this down in a notebook, whatever works for you, so that you have it near you as you do your homework problems. If the coupon rate's less than R sub D, the bond sells at a discount. If the coupon rate and R sub D are the same, sells at par value. If the coupon rate is greater than R sub D, bond sells at a premium. As R sub D goes up, price falls, and in the inverse, of course, holds true. And price is par at maturity. Okay, that's just a good little cheat sheet that'll help you with quite a few of your homework problems and questions. Okay, so what's YTM if the price changes? So everything's the same here, but YTM is now going to drop because the price of the stock, or the bond, is 113,420. So let's type in 113,420. I get 7.08. 7.08. Okay. So as that price went up, yield to maturity went down, right? This increased, YTM went down. Okay, so bonds have yield. Obviously, an investor buys a bond for yield. There's two components to the yield. There's the current yield, very simple formula, annual coupon payment divided by the current price. And the capital gain yield is change in price divided by beginning price. So expected return is the YTM, and the YTM is made up of two components, expected current yield and expected capital gains yield. So again, these are really easy formulas. Just make a note that the yield formulas for slide 21. Jot these down in a notebook so you have them near you during your chapter also. So the question then, if I have a 9% coupon bond over 10 years, price today is $887, yield to maturity is 10.91. What's my current yield? Well, if my current yield is 90, the 9% coupon times 1,000 is 90. Divided by the price today of $887, my current yield is 10.15. Well, I've already calculated that my YTM is 10.91. So the difference between 10.91 and 10.15 is my capital gain yield, which is 0.76. So as long as I know the formula and I know 2 of the 3 parts of the formula, I can solve for what's missing. Okay. The next big part of the chapter deals with semi-annual bonds. And semi-annual means twice per year. Okay, so most bonds are actually semi-annual, meaning they pay interest every 6 months. The vast majority of bonds issued pay interest twice per year. So you have to take your calculation and convert it from annual to semi-annual. It's a really easy process. There's 3 steps. Step 1, multiply years by 2. Okay, so I take the number of years, multiply it by 2. I divide the nominal rate of interest, the coupon rate, by 2, and I divide the interest rate, the market rate of interest, by 2. So I double N, I divide both interest rates by 2, and I'm good to go. Present value, I don't change. Future value, I don't change. Okay, so here's an example of that. So what's the value of a 10-year, 10% coupon semi-annual bond if R sub D is 13? Okay, so 10-year, 10% coupon semi-annual bond if R sub D is 13. Okay, so let's go back to present value of ordinary annuity. That's what I always use when it comes to doing the value of a bond, is present value of ordinary annuity. And let's just start to fill in the numbers. So let's look at the payment. So it's a 10-year, 10% coupon. So 10% times 1,000 is $100. I divide that by 2. So kind of what I have here, 1,000 times 10% divided by 2 is what I'm going to change. So $100 becomes $50. My future value is still 1,000. Nothing changes there. My interest rate, though, they told me that the R sub D, the market rate of interest, is 13. So I take 0.13, I divide it by 2, and I get 6.5. Then this is a 10-year bond. Oops, get the right place here. This is a 10-year bond. And I got to the wrong, let me get the right thing. There we go, 10-year bond. And I multiply that by 2. So 2 times 10 for 20. And I just take 10 times 2. And I get my answer of 834.72, which is my answer right here. So again, you take the coupon rate of 10%, divide it by 2. Future value is good to go. I take my market rate of interest, the R sub D, of 13, divide it by 2. I take the N and I multiply it by 2. And now I have 834.72 as the value of my bond. Okay. So don't worry about this because I've already shown you that with my Excel file. And then the question can be callable bonds and yield to call. So if you're a bond investor and you buy a bond, the question would be, if I buy a callable bond, what will be the value of yield to call? So instead of yield to maturity, I'd calculate yield to call, especially if I believe that my bond will get called. Then I would be thinking about it from that perspective. So it says here, I still have my 10-year, 10% semi-annual coupon bond, $1,000 par value. Sells today for $113,590. 8% yield to maturity, can be called in 5 years at $1,050. Okay, so here's my yield to call calculation. So remember, yield to maturity and yield to call are both solving for interest rates. So I'm solving for an interest rate. I have to go down here and do the solve for I. Okay, let's go ahead and do this calculation based on this being a semi-annual bond. There's one little extra twist we have to be worried about. So it said here it's a, so I expect, it's a 10-year bond, semi-annual coupon, but I think it'll get called in 5 years. So I can't use the 10, I have to use the 5. So my N down here is really 5 times 2 for 10. The future value is not the maturity value of 1,000, it's the call value of 1,050. The present value is what it's worth today. It sells for $113,590. And then the payment, the PMT, is the 10% times $1,000 for, which is obviously 100, and we divide that by 2. So 1,000 times 0.1 divided by 2, and I get this number right here. So this rate here is based on, that's the rate every 6 months. Okay, so I have to really watch the answer here. So this says I'm going to take that number and I'm going to double it. Okay, so when I'm solving for yield to call on a semi-annual bond, and we do this calculation, I have to double it to get the answer. So take that times 2, and I can convert that to the percent here. I get 7.53% right here. Okay. So the key is, if you have a question based on yield to call on a semi-annual bond, use the solve for I, but double the answer. Okay. So if you bought bonds, would you be more likely to earn YTM or YTC? And that's the question here. You'll get that kind of a question in the homework for sure. Coupon rate was 10. Yield to call is 7.53. So the company clearly would be better off by refinancing these bonds, right? They would basically issue new bonds at 7.5%, which is the market rate of interest, take that money and buy off the bonds, and they would save interest. And I would expect to call, because yield to call is 7.5, and yield to maturity on these same bonds, if we did the yield to maturity calculation, it was 8%. So if YTC is lower than YTM, expect a call. Okay, and that's what bond investors are looking at when they buy bonds. I used to work for a company that owned a lot of bonds, and you have software that would kind of do that stuff for you. So you enter the details of the bond, and the software would kind of spit out what the return that we should expect is on that, based on that. So professional investors don't buy something unless they have an expected return based on yield to call or yield to maturity. So in general, if a bond sells at a premium, then coupon is greater than R sub D, so a call is likely. So expect yield to call on premium bonds and yield to maturity on par and discount bonds. Okay, and then this right here talks about all the components that go into the market rate of interest. So as I mentioned earlier, interest rates fluctuate daily in the marketplace, but individual bonds may have different required returns based on a number of factors. So this kind of just shows you what all those factors are that go into determining interest rates on a bond. Whenever you see R star, R the asterisk, just think R star, that's what they call the risk-free rate of return. Generally, we look at the 10-year Treasury bond, and we would say that is the risk-free rate, 10-year T bond. R sub D is required rate of return. IP is inflation premium. MRP is maturity risk premium. DRP is default risk premium. LP is liquidity premium. So again, I'm just going to kind of tell you, have a slide in front of you. This is slide 31. So kind of just be thinking slide 31 will help you when you've got some questions about interest rates. And I've already kind of mentioned what this is, the 10-year T bond. And then, so R sub RF is the basically, now on a short term, I use the T-bill rate. But if I'm looking at bonds, I look at long term, which is the Treasury T bond. If I'm looking at short-term interest rates, I look at the T-bills. And then the inflation premium, the Treasury of the Federal Treasury actually sells securities called TIPS, which are indexed to inflation. So the interest rate you earn as the investor goes up and down along with inflation. But you can get historical inflation too. It's not a hard thing to get. So a bond spread is often calculated as a difference between a corporate bond's yield and the Treasury securities yield of the same maturity. So DRP, the default risk premium plus liquidity premium. Bonds of large, strong companies often have very small liquidity premiums. Bonds of small companies often have LPs as high as 2%. Okay. And then bonds are rated, so any agency, anybody that can issue bonds, so think corporations, state governments, local governments, cities, counties, school districts are rated. And there's 2 ratings companies, S&P and Fitch and Moody's. And so they have different ratings. And this kind of just shows you what their letters. And so what companies do is they basically file information with the ratings agencies, and they say, you know, basically it's giving all kinds of information. The ratings agencies then turn around and give a letter grade. And you can see here that for AAA, in 1 year the default's pretty low. The default risk is, pretty insignificant. Same with AA. But that goes bigger with more time, obviously. But if you get down to the junk categories, the risk of default increases dramatically. So keep in mind, with greater risk, you have to demand greater reward, greater return. So with greater risk, demand greater reward. So the 10-year T-bond, which is no risk, it's 100% risk-free. The reason a federal bond is risk-free because the U.S. government can do one thing that nobody else can do, and that's print money. For better or for worse, they can do that. Okay, so there's no default risk on federal issue bonds because they literally have the power to print money. Corporations don't have that power. Local governments don't have that power. Local governments have the power of increasing taxes, but that's not a guarantee they'll be able to pay things back. Corporations have to have cash flow. They have to have the ability to attract customers so that they have enough customers to be profitable, have positive cash flow, and repay debt. So obviously corporations have more risk because they have to have the ability to attract customers, to have cash flow to repay the debt. Okay, so what factors affect default risk and bond ratings? So think about what the ratings agencies look at. They're looking at your current amount of debt that you have on the books. They're looking at a lot of ratios. So think of our ratio chapter. A lot of the debt coverage ratios they look at very closely. How profitable is the company? How liquid is the company? The current ratio is a big deal. So just looking at ratios, doing ratio analysis. This kind of shows you just what some of those ratios are based on ratings of various companies. Other factors that affect bond ratings. Is the debt secured? Secured debt means there's an asset behind it. Think of if you have a car loan at your local bank, whatever bank you might have a car loan at, if you have a car loan. That's a secured debt. Car loan rates are lower than a credit card rate. Well, the reason is because the car loan is secured debt. If you have a car loan, your bank has the title to your vehicle, and a lien is filed with your local county that says, basically, if something happens, that the bank gets the money from your vehicle. Okay, so if you try to sell a vehicle with a lien on it to a private party, that the bank gets the money first. That loan has to get paid off before you'd realize something. So if you default on your car, clearly the bank has the right to repossess that car. That's secured debt. Senior versus subordinated. Companies may issue what they call a senior note, and a senior note has a priority when it comes to liquidation. If the company were to go bankrupt, a senior note has priority to receive money versus subordinated debt, which does not. Guarantee provisions. There's some guarantee to pay the money back is contractually obligated to be there. A sinking fund is contractually obligated to be there. Or debt maturity. Debt with 1 year maturity is less risk than debt with 30-year maturity. Think of it like that. Obviously, the company issuing the bonds, how strongly are their earnings? Do they have a long history of stable earnings? Is it in a heavily regulated industry? Are they selling products that might result in big lawsuits and things like that? So just think of the business risk that any company is dealing with. If it's a riskier business or a riskier industry, its ability to pay debt, would be impaired. Okay. And this just shows us how interest rate risk kind of dovetails with maturity. If I'm looking at just a 1 year maturity, interest rates changing don't affect bond price a lot. So let's just say I've got a bond with a 10% coupon. But let's say interest rates fall to 5%, the bond price only goes up by $48. If interest rates go up by 15%, the bond price only falls by $43. Because it's just a 1 year. But that same situation under a 10-year, look at how dramatically the bond prices change. So there's risk in interest rates changing on long-term bonds affecting the value of my bonds. And this charts that. This charts the 1 year. That line doesn't change very much. On the 10-year, that line changes dramatically. So interest rate risk is what we're trying to show us. Reinvestment risk is When my bonds mature, what do I do with my money? So corporations that are investors in bonds, as they have own bonds that mature, the question is, what do we do with the cash from our bonds that mature? It says here then the risk that cash flows will be reinvested at future lower rates, which reduces income. So an illustration of that, suppose you just won $500,000 playing the lottery, and let's just say that's the net amount that you get. So let's just say after tax you net $500,000. Your goal, which is a really good goal, is don't spend the principal, invest it, live off the interest. So let's just say you have the option of buying a 1-year bond with a yield to maturity of 10%. Okay, so we can all do the mental math and go 10% times 500,000 would be $50,000. Okay, so I've got $50,000 for that year, and I can live on that. Okay. Now it says, what happens though if in the next year, after your bond matures, it's time to reinvest and buy new bonds? I've got this $500,000 ready to reinvest, and now the market rate of interest has dropped dramatically, and now I can only buy a 3% bond. My income drops from 50 to 15. Okay, so if I was able to go back in time and I had the option of buying a 30-year 10% bond, I've now locked in. It was non-callable, so basically I own it, and nobody can buy it back from me without my permission. I'm locked into that amount now for 30 years. Okay, so that's what to think about. Okay, so maturity risk premium is, again, the longer I have to wait for that bond to mature, the more risk there is. There's less risk if that bond matures in a year, 2 years, 3 years versus 30 years, right? So, but the challenge is that each risk is inverse to the other. So a long-term bond has high interest rate risk, but low reinvestment rate risk. Short-term bonds is the other way around. So nothing is riskless. So companies that do a lot of investment in bonds, what you want is a healthy mix, right? You want a healthy mix of short-term and long-term bonds so you get some kind of a desired return on that. And then term structure in the yield curve. Basically, there's the relationship between interest rates and maturity, and this is called the yield curve. And that's what a normal yield curve would look like. Occasionally, you'll hear what they call an inverted yield curve. With an inverted yield curve, that means that short-term rates are higher than long-term rates. So if you ever hear that, that's what that means. So the normal shape of a yield curve is this one right here. So the yield should go up the longer the years to maturity. And now it's not a heavy increase. But notice that R star, the risk-free rate, really doesn't change much. Inflation will go up a little bit over time, and then the maturity risk premium goes up, as I go further into the future. But that's a normal yield curve. So if you ever see that yield curve dip down instead of going up, that'd be what they call the inverted yield curve. There's a little bit about bankruptcy in your chapter, and obviously because it's in the chapter, you have some homework about that too. There's 2 chapters, Chapter 11 and Chapter 7. Chapter 7 is it's a reorganization and the company survives. In Chapter 7, the company is completely liquidated. So just have that basic understanding, because you have questions about both. And generally, if a company cannot meet its obligations, it cannot afford to pay its debts, it will seek Chapter 11. Most companies will start out with Chapter 11 because that means they can try to reorganize and survive. So if you file for Chapter 11, that gives you 120 days to file a reorganization plan with the bankruptcy court. And during that 120 days, basically there's a freeze. Creditors cannot take action to pursue seeking repayment or trying to shut down the business. So it kind of gives you a 120-day timeout, and the goal then during that time period is to work with the trustee that the court will appoint to you and come up with a plan. And management still stays in control, but major decisions involving money have to be run through the trustee. So basically, you're trying to prove that you're better off alive than dead. in that reorganization plan. And that's what generally most bankruptcy courts are looking for, because the goal is to preserve the company, which means you're preserving jobs. That's better for the economy, obviously, right? You want, maybe the company will not be as large after the reorganization. It won't have as many employees, but the goal is still around, and there's still people employed, and that's good. Versus Chapter 7, where everybody's just, everything's gone. Employees are gone, everything's gone. So clearly that's what you want. So if the company's liquidated, just think of a line of creditors with their hand out, lined up at the business front door, okay? And so there's a line of people with their hand out. Here's the line. So here's where you fall. So we mentioned that secured creditors, right? You've got less risk. Well, you've got less risk because all you're doing is you're waiting for the company to sell secured assets. Once those are sold, I get to collect, right? I'm good to go then. So that's what we're looking at. So that's just the ranking right there. So that ranking may show up in a couple of homework assignments, so just be aware of that. So in liquidation, unsecured creditors generally get 0 because they're so, they're way down the line here. So in a full Chapter 7, there's a good chance they get $0 back. So quite often they may be okay with a Chapter 11 because they'll get something back. They'll have to write off the difference. So something clearly is better than nothing. So quite often unsecured creditors will push for a Chapter 11 because they at least get something back versus nothing in a Chapter 7. So just be aware of that. You'll have a few questions that'll deal with that in your homework, and I just want you to be prepared. As always, if you have questions, just let me know. Thank you.